This video introduces the NetKernel nCoDE composite development environment. During the 10-year history of NetKernel, we've used a demo environment in which we can issue resource requests into a pre-configured set of tools and endpoints to introduce the basic principles of resource-oriented computing. Many of you have probably seen Demo1, which can be installed with Apposite from NetKernel. And it's basically a web form that allows us to type requests and issue them directly into an address space inside NetKernel. So for example, we can say hello world. And we also introduced the concept of the active URI. Here we have a service called XSLT. It requires a transform resource, the operator argument, and some data to be transformed, the data XML. We can issue a request for that, and we get the transformation of the data by the XSLT transform. In doing these demos in Demo1, we're introducing the idea that services are resource identifiable with their URIs, and we have arguments, named arguments, each of which is also a resource identifier. And we show that this basic syntax, this URI syntax, actually expresses an extensible functional programming model. So for example, here's a functional program written in this very low level URI syntax for a transformation pipeline. Here we have a selection of some green data from our data XML and then transformation of that. So let's issue that request, and we see we just filter out the green. Now this demo is always explained that if this was Java being introduced to you, then this is the equivalent in the ROC world of me typing bytecode into the console. You never do this by hand. And over the years we've introduced progressively more simple ways of being able to control and create requests into the address space. What I want to do today is show you the same demo as Demo1, but introduced using the NetKernel nCoDE language runtime. This is the nCoDE environment, and we see on the left hand side a palette of tools, on the right hand side a development environment that we can use to create and issue, create our applications. So first of all, what I'm going to do is do the very simplest version of Demo1, which is to take a resource identifier, and the resource identifier I want to use is resources/data.xml, same as in Demo1. And I want to just source that resource and issue it to the response. So if I now switch to my tab and look at that response, what I see is that data resource coming out. And it's just a dumb piece of XML with some attributes naming the color and a color value inside that item. Okay, so that's a very, very basic hello world. What I want to do is apply an XSLT to that data in order to transform that. So what I have available to me is a transform XSL, and from the XML I can have an XSLT transform tool. I'm just going to close that connection, send my XSLT to the response, make the data the operand argument. Remember, the syntax is operand is the thing to be transformed and operator is the thing applying the transformation. And now I have my data transformed by the transform via the XSLT runtime, returning to the response. If I now look at the demo, I see the color values as I did before. Obviously what we now have is the ability, and this demo here is showing you exactly the same active resource identifier. The palette and the tooling is basically compiled down to the URI requests that we issued in the previous demo. Only now we've got a graphical environment to compose the tools. Obviously what I've got is a very low level XSLT level tooling here. So what I can do is build a more rich and interesting environment. So let's get rid of the XSLT, let's get rid of the transform. Down here I've got an endpoint called HTML table, and it takes an operand argument which is received from outside and transforms it with that style sheet that I used before, transform XSL. and sends its response to the response. So let's add that component to our table, HTML table, and let's just turn the data into a table. So I save that, and you'll see no change. I've now just gone through a higher order version of that same process. Okay, that's okay, but what if I wanted to selectively extract some data from this data set? What I've got here is a simple filter. Again, this does an XSLT transform internally on some data that comes in and selects a color value. That's the style sheet's written to be selective on the attribute that we saw earlier. So let's introduce that component. Here's the filter. And let's introduce the filter to our process. Here's the data. And now I want to selectively add a filter, so let's just drop a filter onto here, and let's filter out the green data. Save that and run it, and now I just have my green data. Okay, this is still not a very exciting application, but it starts to show how we can build up composite systems in the ROC domain. All of these, as I said, get turned into the logical resource identifier for the composite functional URI in the address space. So let's just finally add some bells and whistles. Let's make the pipeline produce a random color, but let's cache that color for a certain amount of time. So what I have here is a random color generator. It's just a piece of groovy code, red, green, blue values, a random integer. We ask for the time to be delayed as an argument, so here we say I'm going to cache it for 1 second, and we create a response from the color value, and then we cache it with an expiry constant offset, so 1 second from now this resource will expire from this pipeline. Okay, so let's get rid of the green and let's just feed this pipeline with a random color. Drop that on. So what now I see is every 1 second, if I keep clicking, my application produces a new resource, but during the lifetime of that 1 second the resource is cached and being served from NetKernel cache. Finally, just to conclude this basic introduction, we've obviously just used some XML tools from this XML palette. We see we've got various things available to us. NetKernel allows us to expose any number of services and make them available as components in a palette on the left hand side. Here, for example, we've got an image library that allows us to do image rotation, crops, scales, etc. Here's a basic image demo. This takes a URL parameter and sources that argument, rotates the image based upon a declarative specification here, 45 degrees, and then finally serializes the image in a PNG format. So this is a universal image transform tool. We need to find out where its image is. It's demo image1. So let's type the URL in of that. And there, for example, is the Google logo. Let's rotate that. That's the URI to the 45-degree rotation of Google's logo.